Moving on in Chapter 4 to Lessons 4.3 and 4.4, Solve Quadratics by Factoring. In Lesson 4.3, we're going to talk about what it means to factor a quadratic function, and we'll use that as a method of solving. Now, factors are simply two numbers that multiply to get a given number, and factors can include both positive and negative values. Now, this can take some practice. Over on the right, let's see if we can determine the factors for each of the following examples. Positive 24. We want to come up with two numbers that multiply and get 24. If you start off with just very basic integers, we could plug in 1 times 24. Those are factors of 24. We could also multiply 2 times 12. 2 goes into 24 12 times. Therefore, 2 times 12 is 24. 3 times 8 would be factors of 24. 4 goes into 24, 4 times 6. There are 4 pairs of positive integers that multiply to get 24. But we should also consider negatives. Negative 1 times negative 24 will still give you positive 24 when you multiply. Same with negative 2 and negative 12, negative 3 and negative 8, and negative 4 and negative 6. Our goal is going to be to work with these pairs and ultimately find a different value with them in our quadratic function. In example B, your answer is negative. So that means you have to have one of each. You'll have to have one positive factor and one negative factor, so that when you multiply them, you get a negative number. So let's think of factors of 9. I know we could multiply 1 times 9, so that could be positive 1 and negative 9. What else could we have? How about negative 1 and positive 9? Those would be factors of negative 9. What else goes into 9? I know 3 times 3 equals 9. So if one of the 3's is positive and the other one is negative, it wouldn't matter which one you write first or second. They would give you a product of negative 9. The last one, 11, finding factors of 11, sometimes all you can do is multiply the number by itself. That's considered a prime number. 1 times 11 equals 11, or we could do negative 1 times negative 11. Now, like I said, if you get some numbers that you're kind of stuck on, just guess and check certain integers. You can use your calculator to figure out if 5 is a factor, 6 is a factor, 11 is a factor. You keep going until you get your entire list. So that's going to be kind of the first part of our process. Now, to convert that to what it means for quadratics, if you want to factor a quadratic function, it means you're actually going to convert it to intercept form. So last week we talked about converting from intercept form and vertex form to standard. This is a way to convert from standard form to intercept form. The rules for factoring. We're going to start when a equals 1. So you'll notice the examples on the right all have a 1 as a coefficient in front of the quadratic term. First thing you want to do is find all the factors of c, which is your constant, and we'll do the steps that we did up above. With all those factors possible, determine the pair that also add to get the b value in the middle. So a common phrase used for this is split the c value to get the b value. Split c to get b. What that means is we split c into factors that add to get b in the middle. Once you know your two factors that multiply to get c and add to get b, we divide it up into two parentheses into that intercept form. We'll have our x minus p and our x minus q. All right, let's put that to the test over on the right. If you have a quadratic function, x squared plus 7x plus 12, and you're asked to factor, you look at the value of the constant at the end. That's your c value. Let's think of factors for 12. I know we could multiply 1 times 12, we could multiply 2 times 6, or we could multiply 3 times 4. And they can be positive or negative. Now the b value in the middle, the answer we want to get when we add them together, is positive 7. Do you see a pair of factors that multiply to get positive 12 but would add to get positive 7? Hopefully you recognize positive 3 and positive 4 would work. Once you find that pair, we split our quadratic into its intercept form with 2 parentheses. We always take the x and split it apart in the first position, x and x. Since both 3 and 4 are positive, we separate that into positive 3 and positive 4. Again, what we've done is we've factored the quadratic function from standard form and converted it to intercept form. And that's all factoring is. In the next example, we have some similar numbers. We have our 12 as our constant, but now this time we want -7. So when we think about our factors of 12, we would want -1 or -12, -2 or -6, -3 or -4, and -4, I guess. So now to get -7, you would want your values to both be negative. Again, once you find your pair, we create our 2 parentheses in intercept form, split the x squared into x times x, and then we do -3 and -4. And this would be the factored form for x squared minus 7x plus 12. For that last example, now look what's happening with c. c is -36. Remember, when your constant is negative, you have to have one of each type of integer in your factor set. One has to be positive and one has to be negative. All right, let's see about -36. We could multiply -1 times positive 36, or we could flip those around. +1 times -36. Oh, 6 kind of got away from me there. What else goes into 36? I know 2 does, so we could do -2 times +18, or +2 times -18. 3 goes into 36. Oh, this might take a while. We could do -3 and +12, or +3 and -12. 4 goes into 36. We could do -4 times +9, or +4 times -9. What else goes into 36? Ooh, 6 times 6, since 36 is a perfect square. We can make 1 positive and 1 negative. That's a lot of choices, you guys. Which pair could we multiply to get -36 and add to get -5 at the same time? Can you see which pair is going to work? I'm going to go with +4 and -9. They would multiply to get -36, but if you added them together, you'd get that -5 in the middle. So that would give us our 2 parentheses, kind of squeeze those in there somewhere. The x squared splits apart into x times x. Since the 4 is positive, I'll put +4. The 9 is negative, -9. And these answers can be in either order, so the parentheses can be flip-flopped, and that's totally okay. All right, let's try some more at the bottom. All right, for our next example, I switched up the variables, but the process is the exact same. P squared plus 2p plus 4. All right, so let's see. We've got c equals 4. Numbers that multiply to get +4, we could do 1 times 4, or -1 and -4. And we can do 2 times 2, or -2 and -2. Now we kind of get stuck on this one. Our goal is to get +2 in the middle when we add. But 1 and 4 aren't going to work. And actually neither will 2 and 2. If we can't find a pair that multiplies to get C and adds to get B, we say that this is not factorable. So no factors work. Therefore, our quadratic function is not factorable. It still graphs a parabola. We just can't split it apart into intercept form and have integer solutions. All right, let's try the next one. M squared minus 10m plus 25. So now we want to multiply to get +25, but add to get -10 in the middle. That means both of our factors are going to have to be negative. All right, what goes into 25? Let's see, -1 times -25. How about -5 times -5? Haha, look at that. -5 times -5 would be positive when you multiply, and when you add them, you'd get -10 for that b value in the middle. When I split apart my parentheses into intercept form, m squared splits into m times m, and both of the 5's are negative, so just -5, -5. If you have the same parenthesis written twice, like a repeat, you can also write it as one parenthesis squared. Either form would be totally acceptable. Okay, final answer. Let's see. Or final quadratic, I should say. What do we have? We have x or r squared plus 19r. 19r plus 84. Oh boy. All right, everybody, here we go. We want to split up 84 into factors of numbers that will also add to get 19. Grab your calculators if you need them. Let's start from the beginning. We know 1 goes into everything, so I know 1 times 84 is an option, but that won't be anywhere close to 19 in the middle when we add. 84 is even. 2 goes into 84, 42 times. That doesn't get us close to 19. 3? Yeah, I think 3 goes into 84. How many times? 28. 28 times. We're kind of getting closer, but we're still nowhere near 19 when we add them together. So keep going. 4 goes into 84 21 times. Yeah, that won't work. 5 won't go in because it doesn't end in a 5 or a 0. 6 goes into 84. How many times? 14. And if you're checking on your calculator and now you're wondering how many times does 6 go into 84, you literally just do 84 divided by 6, and that's how you'd get that 14. That's pretty close. That would give us 20. Does 7 go into 84? Oh, look at that. 7 goes into 84 12 times. And 7 and 12 would add to get that 19 in the middle. I think we've got a winning match right here. They're both positive, so they multiply to get positive 84 and add to get positive 19. Once you know your pair, I'm just going to arrow this down here so I have more room to write. Split up your parentheses. Our variables are, so I'm going to split up the r squared into r times r. And then we have plus 7 and plus 12. So there's an introduction to factoring when the a coefficient is positive 1. I think that's a good stopping point for now. So let's let that sink in and we'll finish up our notes in class.